We are having a class. It is called CSE598, and it is today on the 2nd of April here at ASU. And we have been talking about Windows, and I'm getting flack now for not having work. Right? We need Windows work, Windows homework. Instead, we've just kind of been rambling about Windows, which is fine. So it means the Windows security model is a lot more complicated, as people have pointed out, and that was kind of the point of last week's lectures. I have not read this meme. The class saw me just copy it off the Discord, so hopefully it's PC. It says, against my better judgment, I assume that named pipes in Windows work the same way as Linux, only to be bamboozled that access mode in Windows are not so straightforward and proceed to fall into a trap despite my worst fears warning me. So yeah, that was something you could have done in the prior module. It's something I did earlier today while prepping a totally canned demo with source code already written to follow up on where we ended last week off stream about impersonation. Where it was just like, this made no sense. I drew some pretty diagrams and it didn't go anywhere. But I have something concrete that hopefully doesn't explode. We'll find out. So yeah, learning about Windows without taking or the earlier like 365 stuff about access control makes no sense to give the tackles, the sackles, the all of this insanity. And that makes it hard. But even if you have taken the Orange Belt 365 access control module, it turns out that just Windows security model is complex and deep and messy. One of the things that I said before class, Twitch, I don't have you live. I logged into a computer and then I didn't do it. But one of the things that I said before class is I do not intend on having modules or homework that is specifically about the DACL, SACL stuff. We could certainly build something that does that. I don't think that's super interesting. So I'm going to build something that does that. I don't think that's super interesting. Twitch works. I don't think that's super interesting, so I don't intend on doing it. But we have to kind of talk about that to understand why we do some of the things that we do when we talk about Windows. And it's definitely something that we're going to run into looking at stuff today. I don't know why, but 365 decided to generate some images of me. Apparently, they think quite highly of me. I wanted to generate one. I didn't have time, but asked ChatGPT to generate, a diminished version of me, which is how I felt this week messing around with Windows. Because I ended last week telling you, hey, yeah, just give me until Friday. It's going to be great, right? I just need to finish up this fix of this one bug with an implementation detail. And I did go down and start chasing that bug. And then that turned into, I need to write a kernel module. And it turns out I had not written a Windows kernel module before. So that was its own reward over the weekend. And so now I'm just not going to promise you anything. I just tell you this, right? It feels more honest. And then I don't have to feel guilty when students say like, oh, there wasn't enough work, right? I don't want to feel like I let you down. So instead,
no due date for this week.
I'll let you know. And we'll figure it out there. This is all you get. There will be at least one challenge today. That is all I am guaranteeing you. My loose plan here is that I'll actually be able to get like 6 or 7 live because they're all slight permutations on a small thing. As far as like the first half of what's intended here, and then by class next week, you'll get the back half because that plays on a totally different concept that we haven't talked about. So it doesn't make sense to launch those challenges if we haven't talked about what they involve. The bulk of the stuff that is kind of the first half of this Windows exploitation module is what we're going to talk about today. It's not the DACL, SACL stuff. It's actually, for the most part, not even going to be writing assembly. So it's not even going to be like what we talked about 2 weeks ago. The bulk of what you're going to do in this Windows exploitation module is going to be writing C or C++. I do have a slide deck. Maybe I'll use that as a segue here. Let's not be connected to my home VPN anymore. That would be swell. So the plans for today, I had to grab the latest and greatest dev versions of the code. So we'll see if it's closed. Do you guys have any immediate questions? No, right?
Why is the Windows badge not available on the Windows machines?
Why is
The Windows badge.
the Windows badge?
Yeah. Why can't we see it on the Windows machine?
So okay. So that was yeah, you posted that in the dev channel, right?
Yeah.
And I want to blame your browser. I know you're saying that it's
checked another browser.
I'm here on Firefox. I can see this icon here.
And it's different on Linux as well.
So these icons here are not static images, right? These are just Unicode emojis. And so if you are not seeing it, I would want to blame, I'm not that knowledgeable in the greater realm of Unicode, right? But I would want to blame whatever your font is or your browser is that they don't have a map character mapping for whatever the Unicode bytes are that we're showing for them.
What are you using?
But you're using like Windows 10 or 11, right?
10. I can see it just fine.
Are you on Windows 10? Windows 11?
So I'm not sure. Oh,
Windows 10, for the record, is officially deprecated.
seriously already?
Yeah, dude, my bare metal Windows installs Windows 10, and every time I boot it up, it is like, you must upgrade. Like this is no longer done. And I keep telling it no. And it's like, we're not going to update security anymore. This is all over for you. So I want to take the easy road and just blame Windows 10. I'll look at it this evening on my Windows 10 instance and see if it still looks broken. But that's literally why you would get a box. It's just because whatever it is, whether it's the browser or the font, like the character mapping of what we're showing on Unicode doesn't have a representation. And you're the first to report it. So I was hoping that it just went away, right? That's what happens. That's what happens with all your problems. You ignore them and they go away. So any other Windows questions? That's a fair one. If not, talk a little bit about impersonation, which I didn't talk about on stream. So a recap. If I am here in Windows, and I say, who am I? I am hacker, right? If I start a process, right? If I run, I don't know, fail. Who does this? Now we're live? Oh. So it was, if I just got live, it's probably when I turned off my VPN. So I don't know. Twitch will be spicy. If I run Vim here, who does it run as and why? I'm here in PowerShell. I am the Win2022 hacker user, right? If I run Vim, it's not a trick question. Who does it run as?
Hacker.
Hacker. Why?
That's who you are.
Okay, that is who I am. Okay, how does that work? Right. So on Linux we have UIDs. Right? Is it that it just gets the same UID?
It's impersonating your token.
Okay, so it does have something to do with token. So the way that the whole Windows security model works is every session from the moment I log in has a session token, right? That is what is generated at the time I type in my username and password, and I get my desktop or my SSH prompt, right, appears, right? I've been verified as this user, and I get this token. And we'll see how good my memory is. Get NT token. I didn't send it to format token, but this is all of the type of data that exists in my current sessions NT token. And so it's much more than just a number, right? On Linux, we just have the UID. So like your user 1000 or your user 0, right? This session token represents not only who I am and what groups I belong to, which are something that we've seen in Linux, but they also represent permissions. And so if I were to, for instance, do who am I think all, we can get a listing of the privileges that this token allows me to do. Now, one of the privileges that is
probably not on here. Cool. It is not. No, it is. Is SE impersonate privilege, right? That is the privilege that allows this session to impersonate another user. Now, every time that you start up I'm going to call them child processes. They are not necessarily child processes. But every time that you spawn or create a new process, that process inherits by default your token, right? Now, it is possible, create process EX. Don't make me a liar. Am I a liar? It's not an EX. It is possible to create a process with, that's what I want, create process with token. To create a process with a handle to another token, right? And you'd be like, okay, well, why would I ever want to do that, right? Well, these are all of the privileges that right now PowerShell could do. What if I wanted to spawn another process, but I don't want this child process to, my toy example is like set the time zone, right? I could duplicate my token via the Win32 API and then remove that privilege, right? And what this allows me to do is not escalate privileges, which is what we think of on the Linux side, but reduce privileges, right? So how do we do elevation? I'm going to ignore the obvious answer, workspace, desktop, Windows, which is I'm here in Windows and I right click something and I say I want to run it as administrator, right? This login is actually not something that is admin for demo reasons. But I could right click and run as administrator, and we're just going to hand wave that it is its own magic thing because we're not going to be like attacking that mechanism this week. Instead, if I am an unprivileged user here, the way that I am supposed to interact with something that has higher privilege. On Linux, we have setuid binary. So I'm unprivileged, this binary steps up, right? On Windows, I am forever unprivileged. Instead, I have to trust that an administrator has ran some type of service that is already elevated. All right. And so the functionality that I'm trying to engage with already exists. So who am I here? I am hacker. That works. So if I remember where I hit all these things, this is my elevated server. All right, service. I didn't have time. I was going to actually register this as a service. Does everyone know what I mean when I say a service?
Running process.
So the statement from the class was running process. It's just a service is a process that like spins up independent on its own. It's not running as me. It's running on behalf of the system or some service that it's providing to. I'm using service to define service, right? But it's going to offer some functionality to other processes or user land things that want to interact with, right? And so an example of something that you would run as a service is like a web server, right? You wouldn't typically, even on Linux, you typically don't just say, I'm going to log in and start Apache, right? If this is going to be a web server, we schedule it with, for instance, systemd or a cron job, if you're insane like me, it'd be a cron job. But the rational thing to do is to register it with systemd, and then it's just when the computer starts up, the web server is running, right? And so it is running kind of irregardless of the user being logged in. Unfortunately, I didn't have time to shim this into a service. I don't feel like running through all of this code in great detail, so we're just going to run through it unless you guys really want me to. Which is just going to be primarily like jumping back to documentation and seeing things. First thing I'm doing, which is probably not needed, is I am creating a security attributes. This goes back to the DACL SACL, right? I am trying to make this security attributes be as open and available to anything, right? I don't want to restrict who can communicate with
whatever I'm going to attach these security attributes to. So remember, everything is an object. Now, the thing that I'm going to be applying these security rules to is our friendly named pipe, right? You guys had to interact with this in shellcode a little bit with the flag service. This is how the flag service is implemented. I think the source for the flag service is on the Windows instance. You can see it. It's going to be very similar looking code. All right, so I'm creating the named pipe with whatever that name is, and I'm making it available to everyone, right? I'm making it freely available. All right, we do a ton of error checking because the Win API is extremely verbose. We get this connect named pipe. Connect named pipe works very similar to, what am I? You're going to write a fork server. What do you call?
Accept and then bind.
Accept. Yeah. So this is very similar to accept as far as what the functionality is. This cool. This is not, or this is blocking. Fun fact: I alluded to this overlay thing a little bit like last week. I touched on it and was like, "Oh, this is involved in." It turns out that you can do a ton of I/O asynchronously, and that is where this overlap thing comes in. And so you can do asynchronous I/O for this, where you call something and then you continue even though it hasn't happened. And that's like a built-in functionality of the Win32 API. It gets really wild if you go down that rabbit hole. That was part of my weekend. But this is going to block for someone to connect to that named pipe. Once we've connected to that named pipe, we're going to read some bytes. We just call read from file on the pipe. Cool. We do some sanity checking. This is where the impersonation stuff happens. I have impersonate named pipe client, right? This is the most common way that impersonation occurs. Because this service, it's not technically a service, but this process, I'm going to run it as the hacker user. The hacker user is part of administrators. So this will typically run as someone with administrator privileges, and anything that it creates would use the hacker's session token, right? What this call here to impersonate named pipe client does is it says, hey, tell me who's on the other side. Let me pretend to be them. You'll notice that this is so common, right? This action, I'm not specifying a token. I'm not doing anything, right? The service just says, hey, man, whoever's on the other side, let me pretend to be them. Because this type of impersonation for a service is extremely common. Now, once I have impersonated myself and I've succeeded, so I am now whoever connected to me, all I'm going to do is create a file named hello world.txt, and I'm going to write whatever they sent to me. Where is it? Write file, and this will be what's in the buffer. If I were to scroll back up to this buffer, it'll be whatever I got from the pipe. Okay. We read here from the pipe, that's what's in the buffer. I'm going to dump it to a file. So this is really a stupid service, right? Like it's not doing anything super complicated. It's meant to be about as simple as I could make a demo, right? Where we can understand what this impersonation is doing. And most of the code here is actually error checking, right? Because it is such a verbose API. So then once I'm done, I disconnect the pipe and close the handle, and I return. So it's a one-shot, write something to a file. The client, pipe client, is equally exciting, right? Where we're going to connect to that same hard-coded named pipe, and it is just going to write hello from client, right? It isn't doing anything explicit here to pass a token or send a token down a pipe. It's just connecting to it and saying hello. And then it's done. Easy breezy. Any questions there, right? Pretty straightforward. All right. So now let's start messing around with it. All right, on the left, we will run the server. It's waiting. Oh, let's make sure I don't have hello world here. I do not. Okay. On the right-hand side, I should probably not cover myself. We will run the pipe. Where am I? Oh. On the right-hand side, we will run pipe client. All right, pretty exciting. My question to you is, who owns the file that was created? Why?
Because he uh, the pipe impersonated Stoken and then wrote to the file.
Okay, did I prove anything here? Yeah, did I prove anything? Did I prove that impersonation happened?
Not yet.
Okay.
We'll have to check if we can open the file.
Okay. The other thing, and this is not a fancy Pawn Tools thing, or not Pawn Tools, NT Object Manager function. This is just like a built-in. You can type get ACL to get the access control list for a file. And here we see that this is owned by the administrator. Right. The answer is I didn't prove a dang thing here at all. Right. It doesn't matter if I could cat it. It doesn't matter. Right. Because this could have impersonated someone. This could have not. Who is my left-hand side running as? The hacker user. Who's my right-hand side running as? The hacker user. So if there was no impersonation whatsoever, this still would have worked. Because it's all running with the same, if I were to, who am I? This is hacker. If I who am I here? It's hacker. Right. I didn't prove a damn thing. I just wanted to see if you'd catch that. Okay. So that is why I have this setup here where I am not. I was playing around with this a little bit earlier to verify I am now not admin. And I can't SSH in not admin, but I can log in through the GUI as not admin. Not admin, as the name implies, is not admin. Now, we're going to have some problems here. I want you guys to try and tell me why we're having problems. So we're going to remove hello world.txt. Going to run the service over here. So far, so good. On not admin, I happen to have a copy of the client over here at C, but we can run users, hacker, pipe client. Nope, we can't because I don't have the power, right? That's why we have this copy. We sent a message. Did it succeed over on the other side? Why or why not? The answer is it failed. Why did it fail? I'll tell you right now, error code 5 has to do with permissions.
Access denied.
Access. It's access denied. Why did the server now get access denied?
It says it impersonated successful.
It did impersonate successfully. Where is it trying to write this file?
Can you show the?
Yeah, I was gonna say it's
Okay. No. Like if you something like that's a totally fair ask. What did I call this thing? Pipe X?
Client's not the owner of Hello World.
well, it made it first.
Well, the file didn't exist.
So
Oh,
it
so no.
So nobody owned Hello World because there was no NT file object there.
which directory?
What directory am I in?
in hello or user hacker.
I'm in user hacker. When I impersonate, not admin, can I write a file to user hacker? No. The DACLs wouldn't allow it. Now what happens if I go over here where I am hacker and admin? So I can go into users not admin, and I could run from the home directory, or not the home directory, from the current working directory of users not admin. I'm going to run via absolute path, users hacker. Let's make sure I don't have anything there. Users hacker pipe x exe. All right. We can run our server there. We run our client message sent. Do I succeed? Yes. It says I have written to hello world.txt. Who owns hello world.txt? What?
Not admin.
Not admin. There's some squinting. I appreciate squinting. It means there's thinking. Or you're just really tired. It could be both. You can think and be tired. I claim to do that regularly. So we run get ACL on hello world.txt, and we see that the owner of the file that was created by the service, by our server here, and the server's running as hacker. But it managed to create this file with the owner being not admin. We didn't create the file in like chmod or tronet or the equivalent, right, on the Windows side. We didn't do that. Instead, when not admin connected to this pipe, and we hit, where's the line? Impersonate. This line right here, we invisibly transformed ourselves. Execution from right here onward is executing with the token of not admin. Do you believe me?
Yes.
Have I shown it?
Have you shown the execution tool from that point?
Well, I haven't shown that execution from that point does it.
Yeah.
But I have shown that this is doing that. Right? We can concretely traced and shown everything. I agree. But have I shown you to a reasonable degree that this is what is occurring? That's right. You should always question. Right here, revert to self. This is the undo operation of that. Right. I don't think I mentioned that when I was initially marching through it. So my little server here, it turns into not admin at this impersonation call. And then if I were to make this actually a long running service, at the revert to self, I revert back to whoever I was before, which is going to be the hacker user with administrator privileges. Yeah? All right. Cool. So that is how impersonation works. Now, in order to perform impersonation, you need to have a token that is privileged with that SE impersonate. That was back when I went to who am I? All here, and we said that I'm the hacker user and I have the ability to impersonate a client. That is what this privilege allows this session to do. If I were to duplicate this token and then remove this ability, and remove this privilege, and then run that server, it would fail. It would fail. It would fail at that SE impersonate named type client call because I would not have the privilege to impersonate somebody else. Interestingly, if I were to run the server here, and I use this super awesome run as command, right? You'd think I'm over here, I'm admin, I'm going to run as not admin. Why didn't you just do that, Robert? Right? I could run as user not admin, and what do I want to run? I think it's pipe client. Couldn't do anything.
because
The token that run as is the same as itself. So what's it impersonating? Is it?
what run as is doing, if you, I don't have a man page for it, but we can think of it very similar to sudo, except because I had to type in the password, right? It's not set UID, but it's equivalent to sudo. And so I'm trying to run as not admin and run the pipe client. And at this point, it fails. It fails to connect because the run as doesn't allow you to be impersonated. The token that run as uses is not the same as like your login token. And so it actually breaks this whole thing.
When you do run as not admin, you're running the pipeline with the not admin token.
Yeah.
Okay.
Yeah. It's running it with a not admin token, but it's not a not admin token that is allowed to go out and play with the world. It's a reduced token. Right. And so that also falls apart. And this is just examples of how the nuances of the tackle-sackle, who can do what on what object is just a recipe for all sorts of nuance, right? You can think of it as pain, but think of it also for the power that exists as far as defining and representing who can access something in a large, complicated system, right? Like there's a ton of power hiding behind it, despite the fact that it is extremely messy and verbose for us. So what else did I say we're going to do today here? All right. Oh, injections. All right. I got a whole slide deck for that. You know what? Let's early break so I can pull up this deck because I don't have it on a tab. We'll early break. I'll pull up the slide deck that goes along with that. And this is the meat of what we'll be doing this week. Is this concept of kind of injections and making things happen in ways that we can't do in Linux. So
Return to the people. All right, we are back with an amazing 4 slides and 0 demo. So this will get all hot and exciting. So could it live. The thing that I want to try and touch on here is this concept of injection and hooking is what I'm going to refer to it as. I want to ask you kind of this question. We've seen in the earlier modules, and this is actually a problem that will get fixed. It is not in an intended part of the dojo. That WinDBG can attach to any hacker process when it's just running as an unprivileged hacker user, right? And we said that is the intended behavior of the Windows security, right? It's a little bit weird. How does GDB deal with this?
Something about Petrus.
Something about ptrace.
That's all.
That's true. It is something about ptrace. But GDB doesn't allow us to attach to another process that's running as the same user. Okay. And in fact, the security model, as far as like where are the boundaries on what a process can and can't do, are quite different on Linux versus on Windows. And this should influence how we think about processes. So as was mentioned, GDB leverages something called ptrace. If you went through the Greenbelt material, at some point you did the microarch. And there's those first 5 levels, where they say, hey, write your program, and I'm just going to magically inject some nonsense into your computer. Just trust this hard-coded address that I just display to you. Don't map it. It will just exist. By the time you recognize it, I think I say, like, I'm going to map shared memory into you at, like, 1337000, if you recall. I did that using ptrace. Ptrace is the underlying system that is how you kind of trace and reason and debug processes on Linux. Right? You can look at ptrace, and ptrace looks like a nice unassuming function. Right? It's one easy thing. Do you remember ioctl?
Yeah.
Okay. Ptrace is about as insane as ioctl, if not a little bit more, because it is a Swiss Army knife syscall here, where the meaning of the arguments is dependent upon the flags that we give. And you get these very, very low-level primitives. And this is how GDB works. GDB, if you wanted to write your own debugger, you could. You'd be just calling ptrace a bunch of times to implement it. Ptrace, you fork, you call, hopefully it's in here, trace me. Trace. Really? Oh, there it is. Ptrace trace me. In the child process, that's kind of priming it for saying, hey, we want this to be traced. At that point, when you exec, you get the ability to attach a pre-trace call to the child process and then interrupt and change things around however you want before the process really starts off and fires from main, right? So you can grab yourself, or attach yourself onto a child process and manipulate it however you see fit. This gives us super low-level primitives like peak text, peak data. We don't get to say, give me this giant region of memory. Instead, it's like, give me 8 bytes, right? And like that is what you're getting with the power of ptrace. And so like when I was injecting and executing stuff for the microarch, we were using this tiny little, like, write a word in memory at your RIP, and then executing it, so resetting RIP, and then rewriting those instructions and executing it. There was like 16 bytes of memory, give or take, that I was moving RIP through, stepping RIP through, and then resetting RIP, and then rewriting memory to execute it. Okay. How does ptrace? Well, like, why is int3? Do we know what bytes int3 are? HexCC. Okay. How do you think GDB inserts a breakpoint somewhere?
looks for XCC.
It looks for hex CC?
No,
How does it set the breakpoint? You're right that when it sees hex CC, when it gets that instruction, the CPU triggers, what is it, SIG?
SIG-int.
It's not SIG-int. Is it? That's not SIG-int. I'm going goofy. But when the CPU encounters hex CC, that interrupt occurs. And GDB catches it. But how do we set a break? Like we just say GDB break at this function. How does that work? How does that happen? I don't know, man. The buggers are magic. None of it is magic, right? And that's one of the things that hopefully you can take away from like looking at how some of this stuff works. GDB uses ptrace. Ptrace lets me peek at words and lets me write words. So what GDB does is it uses ptrace to just set memory, and it changes the bytes that are in the text section loaded in memory. It just overwrites it with hexcc, and it does it using the ptrace library. And this is why sometimes if you use GDB and you examine the bytes, I think you can see this. If you were to set a breakpoint on something in GDB and then examine the bytes leading up to where that breakpoint is in memory, you will see the hexcc. If GDB isn't lying to you. I don't know if GDB hides it from you or not. I know you can occasionally see it. But that's what it's doing. So there must be something similar in Win debug, right? Well, there is, except the Win32 API is a lot higher level API when it comes to these things. And this goes back to kind of like dedicated subsystems in Linux that are kind of built in isolation like ptrace versus Windows, where everything has this object-oriented thing, right? Is a process an object? Yeah. Inside the kernel, a process is an object, so I can get a handle to it. And so we can just give me a process. When I attach to something I need to not admin. We need to go be somebody powerful.
I have a small question.
Yeah.
So in Windows, we don't need to be root user to like admin user to attach to a process, right? So I can just open WinDebug and call Win, right? In some of the levels. Does that work?
Call this right now.
Oh, okay.
That's an astute observation.
Yeah.
That is something I'm aware of, and I have mentioned to some other people in private that I'm aware of. So I logged back in as not admin because you asked a good question. Oh, that's going to be ugly WinDBG. Okay. Gosh dang it. Let's do it this way then. Okay. So if I git process and I just want to find something that is running. Isn't that user that I want? Git process, get members. I could have swore it was user. I don't want to talk about that. It's a rabbit hole, man. All right, whatever. We'll use the GUI. I want to find something that is running as not admin. All right, I don't care. This is what it is. And it has a PID of 7040. Do I have CDB here? Of course not. Do I have Z? Yes. Just want to run a debugger and show that I can attach to it. cdb exe PID 7040. Oh, Windows. We can travel back in time, right? This is what I just said you can do. You should be able to attach PowerShell 6796. Gosh dang it. Well, you can attach in general to a unprivileged process as long as you are the owner. The statement was, doesn't that mean that I could just do the equivalent of like GDB level 7 or whatever and call win? The answer is yes. There's nothing stopping you from doing that. But this user that I have made that's named not admin clearly has some problems. Because I put about 30 seconds worth of thought into creating it. Okay. So the takeaway here, what I'm trying to get at, is that we can use these with the same functionality. Do I have calc in here? I do not. CPZ calc. All right. When I run my little calculator here, I can attach to it, I hope. But it's the future. Oh. And one of the things that we saw when we attach is we end up in this NTDLL remote break-in thread, right? We started here every time we attach. This is because the way of kind of debugging with Windows isn't using something like ptrace. Instead, we just inject a thread, right? And we have the ability to do this. So if I were to give you, and this is what the first challenge will be, just calc exe, this calc in particular is not signed, right? But I say this calc exe is the only process that, where'd my calc go? Is the only process that can communicate with the flag service. I'm not going to give you reading in shellcode. I'm not going to give you anything, right? I just say, this calculator is the only binary that's signed on this Windows instance that can talk to the flag service. Can we get the flag?
What are we with the calculator? Like
The calculator's chilling. Right? Like it's here, it's a process. It's being ran as the hacker user. Right? And in the Windows security model, any process can attach to any other process that you run. And we said, because that's how WinDebug does this, it's getting a handle to the process, and then it's injecting a thread into the process that is the breakpoint. So can we write that ourselves? Can I write code that does what WinDebug does?
oh yeah, you can.
I can, and you will, right?
It
But-
was stronger. Yeah.
No, okay. Well, you will not do it, or you will not be complaining about not having work next week. All right, because a lot of Windows exploitation is not done kind of in this low-level shellcode stuff. Right? I could create some contrived scenario where you have to call like 50 Win32 API functions in assembly. That sounds horrible, right? You already enjoyed a little bit of that there. Instead, what do I want to do? I want to open process. That's what's on my slide, if I remember right. What does open process do? All right, NC open process. Give me some dapples. Do I inherit the handle? What's the PID? It's going to give me a handle. What is this a handle to? Right. Yeah, it'll be the handle to the process that I specify for that PID. So let's start doing this. What are we going to call this thing? All right. Do I need to include anything?
Most likely.
Most likely. The default answer is we include Windows.h because Windows.h has literally everything. The other thing from the documentation is if you see something like this, you probably need to include it as well.
Should be Windows.
I'm going to rock it like this, and we'll see. All right. Okay. Let's rock and roll. This is what it says. I want to call open process. I want a handle. Handle, we're going to call it hproc. It's going to equal open process. What are my args? Desired access. Oh no. Can I just use like generic read, generic write?
Let's try.
So the answer is yes, right? If you recall back when we were talking last week, when we were using PowerShell to look at how those generic read and generic write map to specific itemized accesses. The same thing applies here. The question is just like, what access do I really need? You know what's a really nice thing? Just, I want all. Give me everything, right? Because this is a process that is running by me, right? I should be able to open a handle to it. Because remember, the Windows security model is every process has the same power as me. So there's nothing wrong with me being able to go out and touch my own processes. All right, this inherit handle, what does it do? Value is true. If the process is created by this process, will inherit the handle. I don't really care. You understand what that's asking? Right? It doesn't matter for our context. If I were to create another process, can that child process inherit the handle that I'm creating? Doesn't matter for our case. So, false. Last thing, give me a DW process ID, so it's going to be a double word, so it's an int, and it just wants to be the PID. Do we know the PID of the calc? It is 4700. Okay, I have a handle to this process. Now, what good does that do me? Where's my happy slides? Well, it turns out if you have a handle to a process, you can create a remote thread. This is what WinDebug is doing. So we can inject a thread into this process now that we have the handle. Cool. Can we write this? Yes. Let's do it.
It's not thread.
What's that?
It's created a whole thread.
Oh. All right. Security attributes. If it is null, default sounds great. Stack size. If it's 0, uses default. Sounds great. Start address. Okay, now I got a little bit of a problem here. Says the pointer of the application defined function of type LP thread start routine to be executed by the thread. Do I have one of those? It's some fancy language, right? But what do you think it is really asking for here?
Point address.
Yeah, like where do I start reading instructions, right? Where does this thing fire off? I don't have an answer for this yet. I don't know where I want my thread to start executing. So right now, we'll do. So we'll say LP void start footer. Oh no, did I lose my other? I did. Oh, was it null 0?
Yeah, so it's now process again.
I'm good at that, man. All right. LP void start footer, which is just a void star. Okay, so we don't know where we're going, but we can go there. Parameter. Do I need to pass anything to it? I'm going to say no. It doesn't say that it can be null, but I'm a believer. If we don't want any parameters, then that sounds amazing. Creation flag. So this is kind of interesting. Very similar to how ptrace, if you say trace me, you can exec in a child process and the parent process gets to interact before the child process starts running, right? It's like setting a breakpoint really super early in the child's execution. We have a similar thing here with create remote process, where we can, or not create remote process, create remote thread, where we can inject the thread and then start it off in a suspended state so it's not actually running, right? It's not what I want to do here, so I just want my thread to be free. But it's worth noting that you can do that. It does have some useful, it can be useful. And then what do we have here? Thread ID, this is an out, so it just wants a pointer to some D word. What is this thing called? TID. All right. And we'll give it the address of TID. Okay. So I almost right now, just with this right here, have the ability to spawn a thread inside my calculator. My problem is I don't know what start footer needs to be. How do I fix that? Find an address? Okay. I could do that. How do I do that? Right. So now I need to know, like, well, where do I fire off here? Well, in theory, my goal is to access the flag. All right. So I need to make this thread communicate with the flag server and do essentially what you've already done in Shellcode, right? Is that going to be in the calculator somewhere already? Is the calculator right now, as it stands on my system, is it prime and ready? I just got to hit the talk to flag button, right? Talk to flag service. No, right? There is no assembly in this process that's going to do what I want. What do you think I got to do? Well, we could modify memory just like we could in ptrace. We can also just allocate a region of memory inside another process. If I have a handle to it in this calculator, I can essentially call mmap into another process. That sounds kind of useful, right? So let's do that. The equivalent of mmap is virtual alloc. There tends to be, for a lot of the Win32 API, there is a base syscall, then there is a expanded version. To throw yourself into another process, you need kind of this X version here, because we see that it takes a handle to a process.
So we make our own make our own memory.
What's that?
We make our own memory in the calculator to point to instead of like finding one that exists.
Yeah. So the statement was, so we can just make our own region of memory and then we know where it is. Because we should get right here, the address.
But where does this know where to start giving them or adding them?
I'm sorry?
How does this know where to put the memory in our process?
How does it know where?
It's like where will this memory be created?
Well, the highlighted text says
Yeah.
the pointer that specifies the desired starting address for the region of pages you want to allocate.
So
I know the terminology is dense, right? Microsoft has both amazing and horrifying documentation. But how do you parse this language? Or what am I specifying?
so we're going to have a starting address
Hmm.
of what we're about to allocate.
Yeah,
Region of pages.
just like an mmap, if you were to look at the args to mmap, there's a pointer that is like, it's a suggestion, right? I think that was where we like ended like 466 last semester. It was something about the, at least I remember having a distinguished live class where we talked about, this is a suggestion. They do in mmap on Linux, you specify an address, and this is in theory the address where I want the allocation to start, right? Now this could be already in use. It is a request, not a guarantee, but assuming that you pick something that's reasonable, you'll get it, right? We have something very similar here. I am providing a pointer that specifies the desired starting location for where the pages of memory are going to be allocated inside the target process, right? It goes into detail about, hey, this is going to round down, it's going to do something else. So this is very similar. I'm requesting to allocate in some other process at whatever address I define here. So I would know where it is because I'm telling it to put it there.
If it's now the function determines where to allocate the region.
So we have that power. All right. So let's make some memory.
Don't make it before the thing.
You know, you and your fancy logic. Oh, I hear about it, man. All right. We're vibe coding here. So I passed the process. Where do we want to put it? That's the next thing, right? Yep. All right, we'll just use a classic. All right. How big? Let's give ourselves a page. Classic easy number. Allocation type. This has to do with kernels lying to us. Let's just commit. Right?
What does commit mean?
I don't know. I don't read that fast. I just chose something and figured let's break it and find out. Mem commit without mem reserve and a non-null. Well, this says that it would fail. Exactly what I was trying to do. Reading docs might be good. Allocates memory, charges the overall size of memory and page and pulse of disk with specified access. Content. So mem commit is saying I want to allocate it, and then mem reserve is going to be to actually back it. So it's going to be similar to, remember in MicroArch where we pointed out that memory isn't, like virtual memory isn't actually backed by anything until you page fault it. it's a similar idea here is how I'm parsing this. If somebody else sees it differently, that's fine. This is where it's saying it's reserving the actual memory. And then committing it is where we're actually backing it and saying that this will be backed. So the combination of these two allow me to say, give me actual RAM and make it actually exist.
So we're gonna need to call both.
Yeah. I was a believer, man. Okay. Finally, protect. This is going to be something that we've seen already. How do we want this, right? Is it read write? Is it
No access card, no cache, right combine.
yeah. The ones that we care about are going to be the read write execute, right? These right here. Because what do I probably want to map this to be if I'm going to inject some memory into this calculator?
I want to execute.
I want it to execute. What else do I want?
Read.
Not to write.
Yeah. So I want execute read write. Boom. Does this thing return anything fancy?
Yeah, return that.
LP void. The base address of the allocated region of memory.
Let's start.
So that is my start pointer. I agree. Okay, we're almost there.
What does create remote thread return? Or does it not return? Shouldn't think so.
They're asking the real questions. I handled the thread. All right. What else do we need to know?
Right to the memory we just with to the thread, right in the memory of the thread we just made.
All right. Can I just use this pointer?
I don't see why not. It's what the thread is used.
So what process is my main running?
It's
No, what was the question?
So we want to put shellcode inside this process, which is the calculator, at this address. The question is, can I just say start putter equals and start writing assembly? I mean, we assume that I have proper bytes, right? The assembly's good. I have a feeling the answer is no. But
I don't know why.
no, that's fair. Well, what is the return value here? It's a void pointer. And it is the base address. Did this at any point map that address into me? Did we create shared memory doing this? No.
Just some.
Did I create memory inside the process that's running this C code?
No.
Or did I create memory? I created memory in the process that is the calculator.
Yeah.
So do I actually have a virtual memory address right now inside, we're going to call this do.c. No, it's not. It's inject.cpp. But in my inject.exe, is there a virtual memory address that suddenly points to memory inside the process? No. All I did is I made the other process essentially called mmap, right? The Windows equivalent is virtual out. I made memory in somebody else, but I don't really have a pointer to it. Right? We didn't create shared memory that I have a pointer to. I got the address of where it is in the calculator, but that address isn't mapped in my virtual memory space. So there's a dedicated write process memory function.
You may have initially felt like the Win32 API was pain, and you may still feel like it's pain, but there is a rhyme and reason to this stuff, right? Where you can start to kind of predict how you would deal with something. I get the handle to it. There's going to be some Win32 API that specifically allows me to interact with this this object, right? In this way, and all of these are going to correspond to those privileges that we have. All right, so I want to write to the memory of another process. I want to write to hproc. Where do I want to write to? I want to write to start pointer. What do I want to write? Shellcode. All right, so I need that. Let's do cool. Number of bytes to be written. Bytes written. We've seen that again. Pointer to, instead of returning the number of bytes that are written on like read write, we pass it a pointer and it's going to store that result there. And one of the nice things is, what is the type of this? Do you know? Just from the name?
Oh. So, should be numbers.
It's going to be a long pointer to a size T, which should be a D word. Boom. And then, so it's extremely verbose, but you can gain a lot of information once you start understanding the name mechanisms for how the API works. Okay. So now all I need is some shellcode. What do we want to do there? This is the uncanned demo. So let's see if I can do. Is that going to yell at me? Probably. Let's see if that compiles.
Why did you change from double quotes to single? Does that matter?
So in C, a double quote is a string, single quote is a character, right? So this is specifying, assuming I got my syntax right. The curlies is that it's an array, then with one character in it. The idea of a C string, right, is a char star my string, and we would define that with the double quotes, right, as something like this. If you wanted to have that be local, you would say you could do something like this, and I think that would be valid as well. I'm not 100%. But the char star, like when we have double quotes, we're specifying the string, which is functionally the same as if I had an array of characters, right? Right. So here I'm specifying the individual character values of the array of characters. Here, a C string is fancy, fancy syntax to just define the array this way instead of this way. But since I'm only putting one value, I'm going to try and do it this way. I feel like that's better. It'll probably blow up because that's how I do things. All right. Fatal error, cannot open. We got all sorts of problems now. Handle. Oh, that's an easy one. What else do you have problems with? hproc, that's a capital letter.
cannot convert arg2 int on LP void start pointer. Is this something that a nice little cast will fix? No. LP void cannot convert argument. Oh, that's not what it's complaining about. It's mad about this. So let's go back to virtual alloc.
30%.
Okay. I want it to be at the happy address. All right. These are important problems that you will run into. See if it'll let me do that. See, when you move up to these higher level languages and then they enforce rules on you. If this doesn't work, I'll just set it to null and carry on. All right, fine. After this. Yeah. All right. You take your rules and shove it, compiler. All right. What else do I got? Handle create remote thread. Can't convert argument 4. You and your strongly typed languages. Which one? What number? Argument 4 of create remote thread. 1, 2, 3. Oh, that's the same thing. Boom. Okay.
Argument 4.
Argument 4. I thought I just did argument 4. Create remote thread. Create remote thread. 1, 2, 3, 4. 1, 2, 3, 4. Start putter. Line 20. That is line 20. Oh, it's because I have it as an LP void and it wanted to be that fancy start routine. Turns out if I could read. Sure. Sometimes you just gotta know better than the compiler. All right, then it'll compile. Doesn't mean it'll run, but it'll compile. All right. So I have inject.exe. That was pretty exciting. If things worked, how would I know if this worked or not? What's that?
When the bug can tell us something.
Windybug could tell us things. Let's see if I can find my window. Do I not have a? I don't.
I'll post it.
I did have Windybug on it, didn't I? Where am I? You didn't like my 7. It put me at 133. 1330. But we see that I have, and just by writing my own just C program, I was able to, in map memory, inject a thread, start executing it in the context of another process. Right? This idea of injecting is something that is quite prevalent in Windows. When you start talking about malware, you start thinking about viruses. You don't want to have myvirus.exe, chilling on your task manager, right? Instead, you want to try and smuggle your behavior inside of another process. And since Windows processes are extremely multi-threaded, we'll say, it's pretty easy to hide a thread in something. To give you a bit of context, I let the thing that I was writing for the dojo, that you do not have to understand how it works. Do not try and debug this thing. In normal operation, there's like 60 some odd threads going on. Like, it's insanely parallel. And that's just kind of how the mechanisms work over here. So instead, you'll try and inject
your activity into some other benign process. In this case, we need to be inside the calculator because the calculator is going to be the only binary that's going to pass the verification from the flag check, right? So the first level is going to be essentially this, except I'm not writing your shell code, right? And I couldn't finish it here anyways because this calculator that I just copied isn't signed. Okay. So then the question is, well, what are the next couple levels, right?
Wait, before that,
Mhm.
say we did all of that, how do we make sure that that thread actually runs our show?
It is. Where is this CC coming from?
Oh, so as soon as we inject it, it just runs.
So if we were to look at it's a good question. The docs for the start thread or create remote thread,
Oh, we said to no, right? Yeah.
we had the option to make it suspend, right, at start. And we said, why would I want to do that? Right? As soon as I created, I want it to run and be free. Yeah, you'll note that I didn't have to like wait in this parent process. This isn't like a parent child I'm holding the resources of. No, I just created a thread that is tied to the process or thread object that's inside the process, related to the process object inside the kernel. That thread can live on forever and do whatever I want. Now, I didn't write any shell code, but you agree that we immediately started executing. We are at that point, right? Do I have other? Let's display the quad word right there. It's limited to 2. There's my A, there's my B. Well, that's this. So that's the end of it. And then the BC, yep. And then CC. You agree? And so this is something that you can do in Linux for the record, except you'd be using ptrace. So you'd have to have child process, or you'd have to already be root. And if I'm already root, do I really need to do this? No. So how do I turn this idea into more than one level? Because there's several levels that play on this concept. Well, here I did something that we'd call thread injection. Right? I literally injected a thread into the process. You can also force, you remember way back in pwn.college, way back, I think it's not even Orange Belt anymore. There is a challenge where we ask you, it's the last one of program misuse. You never did program misuse? Most people are not fans.
Playing. Sound this.
I don't know where anything is on the website anymore. The very last one, I don't remember what the program is. It'll be in the description, hopefully. Dang, it doesn't say what it is. But whatever this is, this program has the ability to load a dynamic library. Right? That's like pretty common. Like lots of programs may at runtime need to load some type of dynamic library to enable some additional functionality. Well, on Linux, I don't remember what the magic constructor foo is. Let's find out together. Linux constructor DLL on load. There is some magic you can put in a file. I don't want DLL then. Library. Attribute constructor. This is close to what I want. Is that what I want? Yes. So this magic foo here on the Linux side allows you to specify when a dynamic library is loaded. The act of loading the library executes some functionality. There's something very similar on Windows, except it's not this magic foo that you have to have. Instead, if we were to look at Windows DLL, the entry point is going to be DLL main, which is an entry point for when a DLL is loaded. So in the first case here, I just injected a thread right into something. You could also forcefully load a DLL into something. So instead of trying to map all of this, I can just get a handle to a process. I can force you to load a DLL. The act of loading DLL, you're going to call this process. You're going to call this DLL main. And so there's a number of ways to inject behavior into a binary or into a running process. And this would be called like DLL injection.
So do we have to write our own tables?
Sure. Write a DLL. Oh my gosh, DLL, I have to write it. The example here from the documentation is only like 40 lines of C. It's going to be real hard.
40 lines too big.
Right? And now that in and of itself is actually pretty easy, right? The fun of this module is beyond that, because you'd be asking, well, Robert, how are you going, if I'm writing to C, how are you going to stop me from just thread injecting everything? Right? That is where the pain of this weekend finally gets to bear some fruit. So we'll find out if my dev version of nonsense works right now. Live together. So this is going to be an evolving project, right? So the exact implementation will change not only this week, but just over time as I add functionality, because I have stuff that's like halfway working. Right now, I have a couple hard-coded addresses that don't exist on the dojo yet. Make their C. And then I want to copy this. These are all going to be inside the challenge directory as far as the actual implementation, because that makes it way easier for this stuff to run, or without me having to rebuild. Rebuild Windows a bajillion times. All right. So assuming I remember all my hard-coded stuff right, the functionality that I just showed you and said, hey, when debug does it, right? Debuggers do this type of thing. You can do this type of thing. This just exists. If you use it as a debugger, that is great, useful developer context. If you use it as a malicious person, that's evil context. Why do we allow people to do that, right? It has to do with, the answer is kind of like, it's all about what you do with the power, not
What the power is.
what the power is. These same mechanisms of like forcefully mounting a library in, or injecting threads into something, or rewriting another process's memory. These are all the type of things that a EDR or an antivirus would want to do, right? Because when we think about how exploitation works, sure, there could be files that are known bad files sitting on disk, and we could scan all the files that are on the file system. All right, that's cool. But the real interesting stuff is happening in memory, right? And so we want to be able to do things like scan memory if we're the good guys. We want to find what you're doing when you're injecting a thread, right? Is it normal for like a random process to just inject a thread into another one and start doing, is that normal behavior?
Is it?
Well, the answer is it? It's a bit unusual outside of debugging scenarios, right? I'm sure there is some some scenario that I'm not thinking of. But in your regular day to day, no, right? You shouldn't have programs that are forcefully injecting into a calculator, right? That is a bit unusual. And so you can utilize these same techniques from a defensive standpoint. And that is not what you have to do. That's what I did. Now, I had to go a little bit deeper because I went down this rabbit hole of various ways of hooking and implementing things and places to tie in and obtain real-time information. And this is how I ended up with like weird bugs where I'm like, no, I'm going to spawn an infinite number of threads and crash the VM because I wasn't dealing with right data sources. And it's why I had to push things off over the weekend. And then I decided that the correct thing to do was to implement and load a kernel module, which is hopefully what's going to happen right now. So I have Rob Defender EXE. Rob Defender is going to do its best to stop you from doing these various things and getting to the flag.
How's it going?
How is it going to do that? Well, the description is going to give you a loose idea. I don't want to share the source code of Rob Defender right now, both because I'll deploy it, but I am not proud of it. Right? It's been a fun learning process for me here. So somebody on Twitch here says, "I'm just glad I can inject DLL into my Steam games to use cool skins." That is something that you can do. It's not something that I will encourage. I don't know if that counts as a good use of this functionality, but the functionality exists nonetheless. So let's see if this explodes. It didn't explode. I love it. Okay. So on the actual dojo, the intention here is this is going to be running in the background and you will not see it because this is going to be running as a service. Right? As I dev it, obviously, I don't want it to be running as a service because that just makes it harder. So I'm going to try and open up npm. Let's see if this works. Oh, it did. Something horrible has happened. Oh, I know what's happened. Okay, I can fix this. I need, what do we need? Sign tool, sign. You've seen me pull this trick before. Windows crowds, this guy, FD, SHA-256 on Rob Defender. What are you mad at? Sign tool, okay. That I can fix too. What's up? Oh, come on, what do you got? Hit me.
Oh, we're just talking about memorizing that, but then it's on the video.
Well, you don't have to do the sign tool. The sign tool thing will never work for you, right? This is how I'm doing code signing of the challenges. It's the same cert that the flag service is verifying against. It's why you can't just write hello world and then communicate with the flag service. If you can, it's like brutally not intended. And in order to load a that's also going to be grumpy, I think. In order to load, I don't remember if I pushed that. In order to load a kernel driver, it should be signed as well. Gosh, dang it. There's some other step I'm forgetting that is different on my dev environment than whatever is live on the dojo right now. But what am I forgetting?
Maybe we should break and then.
Do you want a break? I'm okay with a break. All right. All right. So I did get things to kind of work, but not fully for very good reasons that I do in fact understand. So if I go into here, we run this guy. It does in fact do something now if I start up a process, right? It right now is grading about rules, and that's because I implemented a dynamic runtime rule-based system, and I'm not going to write a Rob Defender rule file right here, right now. So what this is doing, though, is there is a kernel module that hooks every single process start from the time that this starts, which is why when I started ndim over here, this suddenly fired up. What that is doing is it's leveraging the same stuff that we just looked at. Boom. No, wrong one. Boom. The idea of opening the process, injecting a thread, writing some memory, doing DLL injection, it is leveraging these same techniques, but it's leveraging it in a good way, not a malicious manner. What this is doing then is it's injecting a DLL that is going to leverage something called minhook, which is an open source project you can look up. And it does function hooking on every process. And the reason that it doesn't work right now is because I didn't want to compile like 20 different versions of Rob Defender. Instead, there's this like dynamic mechanism that right now I don't have the rule file for. Hooking or function hooking is the act of rewriting the prologue of a function. So this is the documentation for minhook, which again is on GitHub here. And if we look at the example, the act of creating a hook is pretty straightforward. So we do some initialization, and then we specify a few arguments. Here, what we're doing is we're specifying the function that we want to hook, which is message box W. We're specifying where it is going to go instead of where it's intended, which is this detour message box function. And then we need to provide a pointer where we're going to store the location of the original message box W. The act of this makes it so that when we call, this is hooking itself, so it's not nearly as fancy. But when we call message box W, instead of having this argument here, which we're passing the message box W of not hooked, it's going to say hooked. And the reason for that is that when we call message box W in a userland program, instead it is routing to this detour function. And this detour function is ignoring that argument and replacing it with something else. This same mechanism is being used in this Rob Defender, except I'm hooking various Win32 APIs, all sorts of functionality that you would depend on. So when I say, yeah, you can inject a remote thread into something, or you could load a DLL, how can I force you to not load a DLL? Well, I can inject into every process and rewrite what happens when you call, when you try and forcefully load a module into another process. And I can just send that to a function that's going to terminate. So now that is no longer available to you. And we're going to play a bit of a game of cat and mouse, where the initial one is going to be very similar to what we had here in class, where there probably isn't even going to be Rob Defender, right? Just make it work. Then Rob Defender is going to hook one functionality, then it's going to hook another, then it's going to enable something else. And I'll tell you roughly what it's doing, and you need to figure out how to get around it. You're still trying to do the same thing. You're still trying to talk to the flag service. But you're going to talk to the flag service with reduced functionality, do something weirder. Don't get caught up in this hook of Rob Defender. Now with that, I am going to end the stream because I do have a fully working version of this, but I have to VPN, which will kill Twitch. So I'm going to end that there. The question is, am I in front of a class? I am in front of a class. It's a huge class. They're good though. It's not that huge. All right. With that, I'll leave you all. There will be at least one challenge live this evening, hopefully more. I can't see how I fail to upload calc.exe. All right. I can't see how I fail to do that.
Famous last words.
But at least you have realistic expectations now.